Here's number 27 for the test review. I want you to look at this. I want you to be able to see that there is a GCF here. And yes, you need to take that GCF out first. It's a 2, and you get 4x squared plus 19x minus 5. It's just easier if you do it in the beginning. You can do it later at the end, but in the beginning it makes the numbers smaller. You have a 20, which is 1 and 20, 2 and 10, 4 and 5. You want it to subtract to be a 5, so I'm using 1 and 20. 4x squared, I have an x, a 20x, a minus 5. I'm going to make it a negative 1x so that I get a positive 19. So the 20 needs to be positive. I have 4 terms. I'm going to GCF, x, 4x minus 1. This GCF in the second group is a 5, 4x minus 1. Remember, you should always get like factors here. They should always be the same. X plus 5, 4x minus 1. Combine them. Before you put the box around it, remember at the very beginning you took out a 2, and that 2 has to sit in the front. Number 28, GCF, 2x squared, 5x minus 1. Last group here. Now, if you're kind of stuck and don't know how to find a GCF, look at what you want these numbers to become, because these should end up looking alike. So I'm going to take out a negative 21. Negative 105 divided by negative 21 is a positive 5x. 21 divided by negative 21 is a negative 1. 2x squared minus 21, 5x minus 1, and we're done. (29) GCF. After you do the GCF, you say y minus 2, y plus 2. It's a y squared. It's a perfect square because there's a 4 and you have the negative. You need to factor again. Now, if you do this another way, I'm going to show you this. So this is 29, another way. 4y squared minus 16. I bet you looked at this and said perfect square, perfect square, perfect square. And you said you need 2 binomials. 2 times 2 is 4. Y times y is y squared. 4 times 4 is 16. 1 negative, 1 positive. Nothing's wrong with that. But you have a GCF here. Your GCF's a 2. So you would have to take that 2 out. You have a GCF here. It's also a 2. You would put that 2 right here in the front. And you'd be left with y minus 2. 4, y plus 2, y minus 2. So you get the same exact answer. So you can take the GCF out at the beginning or the end. Doesn't matter. You get the same answer. (30) 81. Well, 81 is 9 squared, so it's perfect square. So y to the third times y to the third is also a perfect square. Perfect square goes into 2 binomials. Y to the third, 9 and 9, minus and minus. You cannot factor again. I know that 9s are perfect squares, but y to the third is a cube. Oops, one of those should be positive, sorry. Y to the third is a perfect cube. You cannot factor again, you're done. Number 30. 30 is a perfect cube. Why? Because x times x times x gives you x to the third. 3 times 3 times 3, or 3 to the third, is 27. So you're going to have a binomial and a trinomial. X to the third, we put an x because that's the cubed root. 27, the cubed root is 3, so we put a 3 here. Notice they stayed in order. Then you have an x, so you need x squared to get you to x to the third. Or you take your first term and you square it. 9 is 3 squared, so you put 9 at the end. So 3 times 9 gives you 27. In the middle, you multiply your cubed roots. So 3x, because those are my cubed roots. Same sign as in the beginning, opposite sign as in the beginning, always positive. So do not worry about the signs till the end. So this is your first cube root, and then you square it here. Your second cubed root is 3, and then you square it here at the end. Multiply in the middle. 32. GCF. How do I know this? There's 4. 1, 2, 3, 4. It's grouping. You should look at a problem. You should be able to see that right away. It's grouping because there's 4 of them. And you go through, you look at what they have in common. I'm doing this one a little faster. There's several examples on here ready. Be careful here. 36 divided by -4 is -9. So 36 divided by -4, -9. Put your GCFs together. 3c minus 4d, c squared minus 9. Now, we have one of those problems where we're not done yet. This can factor again. So 3c minus 4d, I'm done. I'm good. C squared, perfect square, minus sign. 9, perfect square. C minus 3, C plus 3. You have to have a perfect square number, a perfect square variable, and a negative in order to do perfect squares. Looking at this long one here on 33, we got some big numbers. Don't let it throw you off. 64 is a perfect cube and a perfect square. So is 729. But x to the 15th is only a perfect cube. X to the 5th times x to the 5th times x to the 5th. It's only a perfect cube. So we're going to have a binomial and a trie. Do this in order. 729. Type it in your calculator to get the square root, or cubed roots, excuse me, and it's 9 to the 3rd. So you put the 9 first, because 729 came first, then your x to the 5th, cubed root of 64 is 4. Be careful there, do not put an 8. Cubed roots here. Now, 9 squared is 81, so put that there. 10 to the 5th becomes 10x to the 10th. I said that totally wrong. X to the 5th becomes x to the 10th. Because we look here and we already used x to the 5th and I have 2 more left I need to use. So I squared my 9. I had x to the 5th becomes x to the 10th. 4 becomes 16 at the end. So I've gone through and I've squared everything. In the middle here, I'm going to multiply 9x to the 5th times 4. And I get 36x to the 5th. You multiply in the middle. Opposite sign than the first or the beginning problem. Oh my, sorry. Same sign, opposite, always positive. Same, opposite, always positive. That's that soap.